Good morning, afternoon, or evening. Welcome back to Mr. Morrow's Algebra 2 class, Algebra 1 and 2 class. We're just going to have a little review of rational equation word problems involving motion and work. Okay? We're going to involve motion and work. So first we're going to talk about motion. When it was raining, Max drove for 120 miles. When the rain stopped, he drove 20 miles per hour faster than he did while it was raining. He drove for 300 miles after the rain stopped. If Max drove for a total of 10 hours, how fast did he drive while it was raining? So let's think about this, okay? I'm not a genius. I just put things into the table that I created. So first of all, I'm going to go ahead and label a rain data and then non-rain, which would be a sun data. When it was raining, he drove for 120 miles, so my distance is 120. When the rain stopped, he drove 20 miles per hour faster than it did while it was raining. So what do we know nothing about? The rate when it was raining, guys. Look, he drove 20 miles per hour faster than he did while it was raining. So what do we know nothing about? The speed when it was raining. So we call that x. I went the wrong way. We call raining x. The sunny or non-rain is x plus 20. So everyone see that? Okay. He drove for another 300 miles after the rain stopped. So in the sun, he drove for 300 miles. And now, what is the time? Well, the time, he drove for a total of 10 hours. Again, the temptation, because when we've done these problems before without rational, they would give us the distance, they would give us the rate. We'd have values there. And then what we have learned, what I trained you to do was, oh, the time was 10 hours, so he drove X hours in the rain, and he drove 10 minus X hours in the sun. You guys remember that, right? But that's only valid if I have values in all of these. But I don't. I don't have those values. So now I have two different x's for two different categories. I can't do that. Some of you may say, okay, Mr. Morrow, do it with a y. Okay, but now I've got a really nasty system. I've got 120 equals xy, and then I've got 300 equals x plus 20 times 10 minus y. That's going to be a mission. So when you see this problem occur, just remember the equation that you got right here. Distance equals rate times time. So if distance equals rate times time, what does time equal? Divide by r, time will equal distance over rate. So my time in the rain was 120 over x. My time in the sun was 300 over x plus 20. Does that make sense, everybody? Okay. So now, hold on. I want to work this out. I just got to reduce this. Okay, let's bring this down. And let's go ahead and bring this down. Okay, sorry about that. Little confusion there. Okay, let's get back to work. So let's set up my equation, my man. I know that the time that I spent in the rain plus the time that I spent in the sun gave me a total of 10 hours. So now let's go ahead and just solve it. We know how to do this. Remember that I have to distribute this to everything. Okay? But when I distribute x times x plus 20 to 120 over x, the x's cancel. So I've got 120x plus 2400 plus, now the x plus 20s are going to cancel, so I got 300x. And that's going to equal 10x times x plus 20, giving me 10x squared plus 200x. Hope everyone can see that. This over here is 420x plus 2400 equals 10x squared plus 200 x. I'm going to make a trinomial, so I'm going to subtract 420x and 2400 to both sides. That cancels, so I've got 0 equals 10x squared minus 220x minus 2400. Divide both sides by 10. That's going to give me x squared minus 22x minus 240 equals 0. So what times what is negative 240, but when added together is negative 22, negative 30, and positive 8. So x equals 30 and negative 8. You can't have negative miles per hour. So the rate is 30 miles per hour. Yes, sir. Remember the zero product property. I don't have negative 30. I have x minus 30 gets set equal to 0. And then I have x plus 8 gets set equal to 0. Thank you, sir. Yes, sir. What about the 10? 0 divided by 10 is 0. You divided it out. It's gone. It's a number that went into everything. It was a GCF. So I'm allowed to factor out that GCF. Thank you, sir. May I continue? Okay. Okay, guys. Let's see what you got. I'm going to pause it for a second. Let's see what you can do. And then I'll be right back. I'll give you 2 minutes. Go. Okay, boys and ladies out there in the internet world. Okay, what is the distance? Set up your table always. What is the distance that they cycled against the wind? She cycled 30 miles against the wind. Excellent. Now, in the same amount of time that it takes her to cycle 66 miles with the wind. So what's the distance with the wind? 66. If the speed of the wind is 3 miles per hour, what is Maria's speed when she cycles with the wind? Okay, thank you. Against the wind is x minus 3. With the wind is x plus 3. We get to this point now where, again, we have to use time. We're going to have to set it to a variable, but we can't do that. So we remember distance equals rate times time. Time equals distance divided by rate. So this is 30. Well, I did a little bit more fancy this time. 30 over x minus 3. And the time for cycling with the wind is 66 over x plus 3. And now we know, since she cycled for the same amount of time, and I'm not making that up, it was in the problem, says here, she cycled 30 miles against the wind in the same amount of time that it took her to cycle 66 with the wind. You feel me there, guys? Okay, so the time against the wind equals the time with the wind. Boom, we can just cross multiply, basically you're multiplying by the LCD. So it's going to be 30x plus 90 equals 66x minus 198, I believe. Is that correct? Yeah. So this is 36x. I add the 198. That's going to be a 288 divided by 36. What do I got there? It's 8, right, guys? Yeah, 8 hours on the money. So it took 8 hours. So at the end, if the speed was with the wind, what is Maria's speed when she cycles with the wind? It'd be 11, guys. 8 plus 3 would be 11 miles per hour with the wind. Talk to me, please. I'm here to help you. Talk to me, please. I'm here to help you. Sir. So if you just had an X, so what? The question was, what happens if this is x minus 3, but this was x alone? Then this would be 66 over x. I don't know what the answer would be. I'd have to solve it. Oh, okay. No, you got it. You set it up wrong. When would you just have an x? If I told you that cycling against the wind was she cycled 3 miles less per hour than without. But here they told you the speed of the wind, so you had to add and subtract it, going with it or going against it. But if I just told you I traveled for 3 miles per hour less fast than I did doing something else, then that something else would be the unknown x. Thank you, sir. Yes. If you get a mixed number, yeah, go ahead and leave it as a mixed number. 3 and 2/4, so there'll be 3 and 1/2. Perfect. Miles or hours or whatever it is. Yeah. If you want to put it as a decimal, that's fine, but don't get crazy. If you have 5 and 7/16, just leave it as 5 and 7/16 of an hour. If you have 4 and 3/4, then yeah, you can make it 4.75. Trying to make it easy for you guys. Doable. Does this make sense? Because we got to move on. Okay. Now, work. Working alone, Ryan can dig a 10-foot by 10-foot hole in 5 hours. Nobody cares about how much work the job entails. That's one job done. Doesn't matter what they're doing, how many of it that they're doing, how many they're cleaning, how many they're filling, how many they're making, how many they're breaking. What counts is that that's the job. I teach 5 classes a day. That's my job. My work day ends when I've completed those 5 classes. Okay? Does that make sense? Okay. All right. So Ryan can dig a 10-foot by 10-foot hole in 5 hours. So 1/5 of the job is done every hour. Eric can dig the same hole in 6 hours. So 1/6 of the job is done in 1 hour. How long would it take them if they work together? What's the time x when they work together? And this should be a WD. I apologize, because that's work done. The work done here is rate times time. So x over 5, and Eric's rate is x over 6. So Ryan's rate plus Eric's rate equals 1 complete job. 30 to everything, to both sides. So I got 6x plus 5x equals 30, which is 11x equals 30, divided by 11 equals 2 and 8/11ths of an hour. Now, if I wanted to convert 8/11ths into minutes, I'd multiply it by 60, right? It's like half an hour. Half times 60 is 30 minutes. But that will be fine for our purposes. Again, most people don't even do this by hand, the math. But this, there is no calculator as of this point that will do that for you. Okay? Does that make sense? We have questions. Okay, thank you, my friends. Last one, guys. Just wanted to review, okay? I just wanted to review. Working alone, it takes Kristen 11 hours to harvest a field. I should have put a different one. 1 over 11. Kayla can harvest the same field in 16 hours. Find how long. Yeah, it's the same thing. I'm not even going to solve this one. Just the setup. That's my setup. So Kristen's speed plus Kayla's speed equals 1 full job. And then you do the same solving. Does that make sense? Let me pause real quick. I'm going to try to do one more that's a little different, okay? Give me 1 second. All right, guys. So here's one more. This should be a different setup. Okay, it's not as fancy. I just looked it up, so let's work it out together. 1 pipe can fill a pool. Well, first of all, it's a work problem. So rate times time equals work done. And I have 1 pipe can fill a pool in pool 1.25 times faster than the second pipe. So we got first pipe and second pipe. This pool, the rate is 1.2 times faster than the second pipe. I have no idea what the second pipe's rate is, so I know it can do 1x of the job every hour. The first pipe can do 1 over 1.25x of the job per hour. Are you with me there so far? Okay. When both pipes are open, they fill the pool in 5 hours. So working together, they fill it in 5 hours. Okay. How long does it take to fill the pool? Well, the work done by the first pipe is 5 over 1.25x, because that's the rate. And the second one is 5 over x, because that's its rate. Okay? Does that make sense? Okay? So, the rate of the first pipe for 5 hours plus the rate of the second pipe for 5 hours equals 1 complete job. I'm running out of time here, guys. Is it okay if I don't solve this? Yes, sir. I don't know. He asked me about a different setup. I know how to do it this way because it makes sense to me. Do it both ways and see if you get the right answer, sir. Okay, what don't you understand, though, about my setup so I can help you? Does this make sense to everybody? Remember, guys, the LCD here is 1.25x. So that's what you're going to multiply to both sides, okay? Now, give me 1 second real quick. I'll look up the answer, and then that way you know if you got it. The answer is 9. Well, x equals 9, but then when I plug it in, it'd be 11.25. Yes, okay. Okay, guys. When you do this, the answer is 9. Okay? X is 9, but they're asking for how long would it take to fill a pool. If only the slower... if only the slower pipe, it's 9. Yeah. And the faster pipe would be 9 times 1.25, which is, I think, 11.25 or something like that. Okay, does that make sense, guys? You got the setup? You ready? All right, let's knock this out. Thank you very much, guys. I hope this benefited you.